In this video, we'll go ahead and take a look at how to graph a linear equation in two variables and talk about slope of a line, which is what the graph of a linear equation is. So we got two main objectives here. We want to be able to graph a linear equation in two variables and be able to find the slope of a line and use it to graph a line. So um, we just got done talking about relations and functions. And in this section, we're going to talk about linear equations, which when you'll see here in a sec, end up being functions. So this is kind of the first specific function that we take a look at. So, all right, so we're getting ready to graph linear equations, and we graph those on what's called a rectangular coordinate system. So it's the coordinate system you're used to. We have a vertical number line called the y-axis, and we have a horizontal number line called the x-axis. The variables could change, so usually it's x and y, but sometimes we have other variables. So the vertical axis typically represents what's called the dependent variable, and the horizontal axis represents what's called the independent variable. But typically it's x and y. So anytime we switch it to different variables, we'll talk about it specifically at that time. So this vertical number line and this horizontal number line, they divide the plane into four parts. So we call this one right here quadrant 1, right here's quadrant 2, right here's quadrant 3, and right here's quadrant 4. And where those two number lines intersect is called the origin. So that would represent 0 on the x-axis and 0 on the y-axis. So this picture, this x-axis and y-axis, it goes by lots of names. The most common ones are the xy plane, the coordinate plane, and sometimes it's called the Cartesian plane, named after a mathematician by the name of Rene Descartes. I don't know if I pronounced that right, but so xy plane or coordinate plane is typically what I'll call it, but Cartesian plane does pop up from every now and again. So let's remind ourselves how we plot a coordinate or a point on the xy plane. So we need to plot 2 comma -7 halves. So we'll go ahead and sketch a xy plane or coordinate plane. So graph paper is always handy, but if you don't have graph paper, just be careful. We don't try to draw as neat as possible. So a vertical axis and a horizontal axis, make sure you label which axis is which, and it's very common to only put arrows on the positive ends of the axes. There's good reason for that. We'll talk when you graph a horizontal line, it helps. We'll talk about that here in a sec. So let's plot 2 comma -7 halves. Well, we need tick marks to let us know where we're at on these number lines. So typically, if the tick marks are not labeled, then they're understood to be 1 unit apart. So this would be 1, 2, 3, so on and so forth. So if they're not labeled, it's understood to be 1 unit apart. So if I'm going to plot 2 comma -7 halves on the xy plane, well, the first number represents where you're at on the x-axis. So we're going to go +2. So we're going to go 2. We're going to go find 2 on the x-axis, which and then the -7 halves represents where you're at on the y-axis. So that would be -3.5. So 1, 2, 3. So if this is -3 and this is -4, we'd be at -3.5, which would be halfway between those. So what we do is to plot this, we kind of picture a line through 2 and a line through -3.5. and where those intersect would be where we plot the point. So where they intersect would be where we plot the point. So basically 2 comma negative 7 halves basically says go right 2 and then go down 3.5. So right 2 and down 3.5. So this right here is the coordinate 2 negative 7 halves. Alright, so the first coordinate, the left coordinate, is typically what we call the x coordinate, and the right coordinate, or the second coordinate, is the y coordinate. They do have other names, some old-timey names. This is also called the abscissa, and this is also called the ordinate. So usually we say x, y. The reason they have other names is we don't always use the variables x and y. So if we don't use the variables x and y, then those names change. But no matter what the variable is, the leftmost one's called the abscissa and the rightmost one's called the ordinate. All right, so now that we kind of reminded ourselves how to plot points, um, let's review what a linear equation in two variables is. So first off, it's got to be an equation because it's a linear equation. We need two variables, typically two different variables. X and y are the most common variables that we use. But most importantly, it needs to be an equation that when you graph it, you end up with a line, a straight line. So a linear equation is one that when you graph it, you end up with a straight line. So linear, the first four letters, L-I-N-E, for line. So some things to remember. When we say a solution to this kind of equation, solutions to equations that have two variables are ordered pairs x comma y that when substituted into the equation result in a true statement. So when we say that a solution to an equation that has two variables, we're talking about ordered pairs that when you plug them into the equation, you get a true statement. So for example, let's say we have 4x minus 2y equals 7. So it's definitely an equation because we have our equal sign. We've got two different variables, x and y. So the ordered pair 0, comma, negative 7 halves is a solution. And I know that because when I plug 0 in for x and negative 7 halves in for y, 4 times 0 is 0, negative 2 times negative 7 halves is positive 7, so that equals 7. So this is a true statement. So this ordered pair is a solution to this equation. So let's contrast that with the ordered pair negative 1, comma 3. That one is not a solution to this equation because when I plug negative 1 in for x and I plug 3 in for y, I end up with negative 4 minus 6 is negative 10. Well, negative 10 equals 7. That's a false statement. So that would not be a solution. Well, when you graph an equation that has two variables, the graph is basically all of the solutions x comma y for that equation. So basically what that's saying is when you graph an equation, you're graphing its solutions. So when we ask you to graph something, we're not asking you to graph it just because the graph looks cool or it's, kind of like art class. When you graph an equation, you are literally graphing all of its solutions, all the ordered pairs that solve that equation. So it's a visual representation of where all the solutions are at for that equation. So let's look at an example. So if we ask you to graph the linear equation 3x plus 2y equals 4 by first finding 5 solutions. So we've asked you to graph this in a specific way. I want you to find 5 solutions to that equation and use those to graph. So if we take 3x plus 2y equals 4 and rearrange it so that y is by itself, it'll be a little easier to find solutions. So we like to keep our solutions organized. So typically we create what's called a t-chart, where x is on the left-hand side and y is on the right-hand side. The x values represent the domain and the y values will represent the range. And there's an infinite number of x values possible for this equation, and then therefore an infinite number of y values that go with them. So we're not going to be able to write them all out. I just asked you to find 5. So I just want you to pick 5 x values. So I'm going to pick -2, -1, 0, 1, and 2. And we're just going to plug those in to this equation to see what y is. So if we plug -2 in, -2 times -3/2 will be 3 plus 2 is 5. If we plug in -1, we end up with 3/2 plus 2. So we end up with 3/2 plus 4/2 would be 7/2. If we plug in 0, we end up with 2. And if we plug in 1, we end up with 1/2. And if we plug in 2, we end up with -1. So these are ordered pairs that are solutions to this equation. If I plug that ordered pair in for this equation, it'll be a true statement. So we end up with 5 solutions. Now there's lots of x values we could have picked. So there's a lot more solutions, but we can't write them all down. We don't have that kind of time. So what we do is we graph the solutions on the xy plane. That way, whoever's looking at the graph can go see basically where all the other solutions would be at. So let's go ahead and put some tick marks on our axes. And our first one's -2, 5. So that tells us to go left 2 and then up 5. So 1, 2, 3, 4, 5. And then -1, 7/2. So it's -1 and 3.5. 0, 2. 1, 1/2. And then 2, -1. And then as you can see, these follow along a straight line. So we'll just continue the pattern by drawing a straight line through those points. Now when you draw the graph of any equation, make sure you draw the graph out to the edges of your xy plane. So all of the coordinates along this line are solutions to this equation. And since the graph is a line, it's a linear equation. So there's an infinite number of solutions that lie along this line that would solve that equation. And this graph shows whoever you're graphing it for, it shows the audience where typically or approximately where all the solutions would be. All right, so linear equations, they can be written in 3 very useful forms. So these should be familiar from Algebra 1. The first one is slope-intercept form. So slope-intercept form is extremely useful when you want to graph a line. So slope-intercept form is basically where the equation is solved for y. So if you solve it for y, you'll get some number in front of x plus a constant. Well, the number in front of x we call m, and that's the slope of the line. And that constant at the end is the y-intercept of the line. So slope-intercept form is what is very, very useful when you want to graph a line. But there's also point-slope form. Point-slope form is extremely useful when you need to write the equation of a line. So you don't know the equation. It's up to you to come up with it. So we use point slope form for that. Basically, our variables here, y minus y1 equals the slope times the quantity x minus x1. Well, m is the slope, and x1, y1, that's an actual coordinate or solution for the line. So if you have to know one coordinate on the line and the slope. So this y and this x, those are the variables. The y1, m, and x1, those are constants. And then the other useful form for linear equations is standard form. So standard form, we don't use it as much. The main reason we'll use it this year is when we solve systems of linear equations, which we're not there yet, but we will be soon. Standard form is basically when x and y are on the same side of the equation. So if you have, a is the coefficient of x, b is the coefficient of y equals some constant c, that's standard form. And there's a couple restrictions. A and b cannot both be 0 at the same time because then we wouldn't have any variables. And we like to have the front number be positive. The front number could be 0 too, but we don't like it to be negative. So these first two we're going to use quite a bit. So right now let's use slope-intercept form to graph a line. So right now it's in standard form. So we have 2x minus 3y equals negative 9. So the x and y are on the same side of the equation, so it's in standard form. But we want to graph it. So when we graph, we like slope-intercept form, and that's the one where we solve for y. So let's move 2x over to the other side, and then divide by negative 3, and we get 2/3 x plus 3. So we've solved for y. The number in front of x is the slope. So our slope is 2/3, and then the constant is the y-intercept. So our y-intercept is 0, 3. Now with those two pieces of information, we can graph this line. Now one of the things I want to remind you is 2/3 is the same thing as negative 2 over negative 3. Negative divided by a negative is a positive, and you'll see why that's handy here in a second. Alright, so let's go ahead and draw a coordinate plane, XY plane. Put our tick marks. Well, we know one coordinate or one solution to that equation is 0, 3. So we'll go plot our point at 0, 3. And then from that point, we'll use the slope. So back in Algebra 1, you might have called the top number the rise and the bottom number the run. So it's 2/3 or negative 2 over negative 3. Well, let's use the 2/3 first. So that would tell us to go up 2. So we would rise 2. And then since it's positive 3, we'll move 3 to the right, or we'll run 3 to the right. So we'll rise 2 and run 3 to the right. But I also wrote down that it was negative 2 over negative 3, because you could also go down 2 and left 3 would also work. And then you can repeat that as many times as you want. So I can go down another 2 and left another 3. And then you just get as many points as you want, and then you carefully draw a straight line through your points. So our slope, we rise 2 and we run 3. When you go the other direction, you go down 2, left 3. But either way, if you pick any 2 points along this line, the slope should be the same. Rise 2, run 3. All right, let's graph another one. Let's try this again. So let's graph y equals 4. So we're going to graph again, so we like our slope-intercept form. But if you look, there's no x. But that's okay. The reason there's no x is because there must have been a 0 in front of it. 0 times x would be nothing. So you just have y equals 4. So we'll just put the x back in there with a coefficient of 0. So the slope would be 0 over 1, which is the same thing as 0 over negative 1. And our y-intercept would be 0, comma 4. So we'll go ahead and draw a coordinate plane, x-axis, y-axis. Put our tick marks on there. And we'll plot our y-intercept, so 1, 2, 3, 4. And then our slope, we rise 0 and we run 1. So if our rise is 0, we don't go up or down at all, but we run 1. So we can go 1 to the right. Or you can do negative 1, so 1 to the left. And then we don't rise anything at all, so we can go 1 to the right. We don't rise anything at all, we can go 1 to the left. And eventually you'll see this is just a horizontal line. So if you ever have y equals a constant, like there's no x variable at all, then you just have a horizontal line. Now earlier I mentioned we don't like to put arrows on the negative part of the axes, and this is one of the reasons why. Typically, if you're just doing all your work in pencil, then when you graph a horizontal line, it's hard to tell that apart from the x-axis. But if you put arrows on both ends of your line, but you only put an arrow on the positive side of the x-axis, then it's really obvious which one's the axis and which one's the horizontal line. All right, let's graph one more. This time we have x equals 7 halves. 7 halves keeps popping up a lot. Let's change that. Let's do negative 5 halves. Well, this time there's no y, so we can't solve it for y. Well, what that means is since there is no y at all, then basically it's very similar to the one we just did. When it was y equals 4, that means all of our solutions, all of our ordered pairs had to have a y value of 4. Well, down here, x equals negative 5 halves. That means that all our solutions have to have an x-coordinate of negative 5 halves. So on the coordinate plane, if all the x-coordinates have to be negative 5 halves, which is negative 2.5, then that could be a solution because the x value is negative 2.5, so negative 1, 2.5, or any other coordinate that has the same x value. So that ends up just being a vertical line. So this is basically a vertical line through this is just a vertical line through negative 5 halves. So vertical lines have undefined slope. So the slope is undefined. The slope is not a number. It just doesn't, the slope has no meaning for a vertical line. So vertical lines just have no slope whatsoever. All right. Let's take a little bit closer look at slope itself. So let's say you have a line and it passes through 2 points. So it passes through, let's call this first point x1 and its y value y1. So the x coordinate is x1, the y coordinate is y1. And then later down the road it passes through x2, comma y2. So we got 1, 2 coordinates. And then there's our line that goes through it. So We know you might know slope from Algebra 1 as the rise over the run, which is okay, but we want to start to think of it in a little bit more technical terms. Basically, we just need to know how far apart vertically this coordinate is from this coordinate. We just want to know how far apart they are on the y-axis. So to find distance between two numbers, you can just subtract them. So we'll just take y2 minus y1, y2 minus y1, and that's how far apart those are. Well, in math, we would call that the change in y. So this triangle is called delta. So delta y, delta represents change in mathematics. So this is the change in y, or what you probably called the rise in previous math courses. Well, we divide that by the run. Well, the run is just how far apart are the x coordinates. So if I take this x coordinate and I subtract this one, it tells me how far apart they are, or the change in x. So this is delta x, or the change in x. And we know slope is rise over run. So it's the change in y over the change in x, which we just talked about. You just subtract the y coordinates and you subtract the x coordinates. So this is a little formula that will give you the slope of any line. So you just subtract two y coordinates on the line and then subtract their corresponding x coordinates. Now you gotta be careful, since it's subtraction, it does matter the order that you do this in. So I always just do the second y coordinate minus the first one, and then the second x coordinate minus the first one. And keep in mind, since there's division, you can never divide by 0. So this number and this number cannot equal each other. So these have to be two different numbers on the bottom. So let's use that real quick. So let's write the equation of the line that passes through these two coordinates. Now earlier we mentioned that we want to use point slope form to write the equation of a line. So I don't know the equation of this line yet, so we're going to write the equation. Well, to do that we need the slope. So slope is the change in y divided by the change in x. So we subtract the y coordinates and then we subtract the x coordinates, and we end up with 3/4. So we plug 3/4 in for m, and then you can pick either one of these coordinates. Both of these are on the line, so both of them are solutions to the equation. You can pick either one. So I'm just going to pick the first one, and you plug the y coordinate in and the x coordinate in, and then we simplify. We typically like to solve for y. That way, if we wanted to, we could graph it. And in this case, I think we get -11/4. So if we wanted to graph it, the slope would be 3/4 and the y-intercept would be at -11/4. So the little formula to find slope comes in handy here. That way we can find the slope between these 2 points and plug it into point slope form. So here's the equation of that particular line that passes through those 2 points.